Hello everyone. As we know, the main function of the subgrade is to support the pavement. So, for highway engineers, we must pay attention to the subgrade quality. Today, I will introduce the fourth chapter, Subgrade Design, which is based on the specifications for design of highway subgrade, JTG D30 2015. This chapter includes 4 parts: introduction, road bed design, and cross-section design, subgrade slope protection and retaining structures, and subgrade drainage. Now, let's study the first part, introduction. In this part, I will introduce the following contents: cross-section types, highway subgrade types, design considerations, and the key tasks of subgrade design. Highway subgrade geometries are dependent on their locations in the road alignment. Highway subgrade can be divided into 3 types, namely embankment, off-fill, cut, and fill cut. Embankment or fill section means the subgrade surface is higher than the natural ground elevation. Additional materials should be borrowed to form the subgrade, as shown in this one. Cut section means the subgrade surface is lower than the natural ground elevation. Excavation is needed to form the subgrade, as shown in this one. Both fill and cut are existing in the same subgrade cross-section. This type of subgrade is called fill and cut, as shown in this one. According to the Chinese engineering practice, the subgrade cross-section is composed of the subgrade width, subgrade height, and the subgrade side slope. Followed are the definitions of the 3 key elements. The first, width. The subgrade width is mainly composed of travel lines, central reserve, and road shoulders, as well as the emergency stop area, climbing line, and so on. The width is dependent on highway classes, design speed, number of travel lines. In common, the width of travel line is from 3.5 to 3.75 meter. The shoulder width is from 1 meter to 3 meter, and the central reserve is about 2 meter to 3 meter, which depend on the highway class. The second, height. The subgrade height is the height of filling materials or the depth of excavation. Since the original ground may have a slope, the height at the road center is different from that at road edges. The center height and edge height should be distinguished. The center height is the distance between the design elevation of the subgrade center line and the original ground, while the edge height is the distance between the design elevation of the subgrade edge line and the fill slope toe or the cut slope top, as shown in this figure. The third, slope. The subgrade side slope is defined as the ratio of the subgrade height to the slope width, which is denoted by 1 to m for the fill subgrade and 1 to n for the cut subgrade, as shown in the fill section. The subgrade height h equals 2 and the slope-wise b equals 3. Therefore, the slope is 2 to 3 equals 1 to 1.5. As shown in the cut section, the subgrade height h equals 5 and the slope-wise b equals 2.5. Therefore, the slope is 5 to 2.5 equals 1 to 0.5. Based on the subgrade height, fill subgrade can be divided into the low fill, high fill, and ordinary fill. When fill height is less than subgrade work area depth, it can be defined as the low embankment, just like this one. When the edge height is higher than 20 meters, it can be high fill, as shown in this one. For the ordinary fill, the height is between the low fill and the high fill. Based on the cut edge height, cut subgrade can be divided into ordinary cut and deep cut. When the edge height is less than 20 meters for the soil slope or 30 meters for the rock slope, it can be defined as the ordinary cut subgrade. Well, for the deep cut subgrade, the height is deeper than 20 meters for the soil slope or 30 meters for the rock slope. According to the cut cross-section, cut subgrades may be divided into the full cut subgrade, benched cut subgrade, and half tunnel subgrade, as shown in the pictures. In the full cut subgrade, slopes can be straight lines, polygonal lines. Side ditches are built at the slope foot for drainage. Interception ditches are built at the top of the slopes for intercepting waters. For the benched subgrade, which is built on a steep hill, the road center should be close to the inner side or inside, for the purpose of avoiding field work. For the half-tunnel subgrade, for saving rock excavation work, the road is built on the hill with harder rocks. A typical structure of a full-cut subgrade consists of the fill part and the cut part. According to the cross-section, there are many different types, such as ordinary fill cut with low retaining wall, fill cut with road shoulder protected, fill cut with masonry wall, fill cut with supporting retaining wall, fill cut with hillside bridge, fill cut with masonry slope. Next, I will introduce the factors that should be considered in subgrade design. As we know, the natural conditions, traffic loading, cross-section types affect the survivability and the distresses of the subgrade. First, we should consider the natural conditions. Natural conditions include climatic conditions, hydrology, landform, geology, earthquake, filling materials. The climatic conditions mainly mean the temperature and water. The combination of water and temperature will cause frost heave and soil settlement, which should be considered in construction and survival phases. Settlements after construction should be considered for fine-grained soils. Fill materials should meet requirements of subgrade capability. Second, traffic loading should be considered. The traffic loading is the pavement-tire interaction pressure, which directly applied to the pavement surface and then transferred onto the underlying lanes. Traffic loading will affect the working area depth and make the different road bed thickness. The slope stability is dependent on the subgrade soil shear strength, the side slope, and the traffic loading. When we design the retaining structure, the traffic loading is one kind of factor to induce the force acting on the wall. Last, we should consider cross-section types. Designing the subgrade, we should consider on the cross-section types, such as fill, cut, or fill cut. Deep cut and hill fill subgrades should be avoided if possible. If the fill height is more than 20 meters or the cut depth is deeper than 30 meters, the subgrade approach should be compared with the bridge, tunnel, or separated subgrade approaches. When the land is limited, retaining structures should be considered. Okay, we have already known the consideration of the subgrade design. Next, let's study the key tasks of the subgrade design. The first step, data collection and analysis. The data are from the design assignment, the key requirements from specifications, and other relevant information. We should know the following: highway class, such as the road is belong to expressway, first class, second class, etc. Climatic conditions in the region, which may include temperatures, annual rainfall, adjacent water sources, and etc. Geology conditions along the road, which include landform, geological structures, natural hydrology, earthquake, feeding materials, sources, etc. Traffic loads is focused on single axle loads. Potential pavement structure, such as the asphalt pavement structure or the cement pavement structure. And then the second step, the road bed design. Based on the working area depth, the road bed thickness may be determined. According to the National Subgrade Design Specification, the road bed soils should meet the CBR compaction requirements and the road bed structure capability. Third step, subgrade cross-sections design. The key is to determine the width, height, slope, filling materials, etc., especially the slope. Fourth, in order to avoid the water affecting subgrade, the subgrade drainage design is carried on. Last, in order to guarantee the subgrade stable and durable, it's necessary to design slope protection and retaining structures. Okay, let's summarize the section. I have introduced the following contents: cross-section types, highway subgrade types, design considerations, and the key tasks of subgrade design. Thank you for your attention. See you next time.